Hey folks, Jamie Lindell here. Just going to talk to you today about kind of the next step in doing twisted Damascus. So we've gone over how to create different patterns and how to manipulate some of that. We've gone over how to actually do the twisting itself. And now I'm going to talk to you a little bit about putting those bars together to make a multi-bar stack. So there are two different ways that you can put these bars together. The basic way is that, and then the fairly standard way, is to put them together like this has been assembled, which is putting the bars next to each other, making sure that you're pretty close, you don't have much in the way of gaps, and then running a bead, a weld across those lines. I do that with my TIG welder, and I generally do that without adding fill if I can avoid it. That all being said, I know plenty of folks are doing these multi-bar patterns with MIG welders and just adding that extra material. The downside of adding the extra material is that stuff that you have to remove later on, because that's not going to match either your 15N20 or 1095 or whatever kind of high carbon materials you're using. You know, you're putting mild steel in there, and that's going to show up if you don't remove that material. So you want to be careful of that. However, if you recall back in the video that we did previously about creating patterns and the depth at which you want to cut in order to reveal a good pattern in your twists, you'll recall that you want to go in, you know, close to 20%, 25% is when like you really start getting interesting look in your pattern. So if you're planning on just removing that material anyway, using that TIG welder, using that MIG welder with fill is not going to be at all a problem. You're going to remove it anyway, so you know, why go through any extra effort or make things more complicated. However, if you're going to be putting together a multi-bar pattern and you want to maintain some of that outer look of that of the straighter diagonal lines, or if you're doing something like a wolf's tooth pattern or something like a chevron or braid pattern, what you might want to do, sometimes all that stuff doesn't meet up perfectly and you end up with gaps, and filling in those gaps with weld material isn't really going to help you out too much, because you're going to end up with a blob there. So what I like to do in those scenarios is I'll cut out a piece of 20 gauge mild, and when I put my bars together, so you know, you want to make sure that obviously your surfaces that you're welding together are nice and clean. Once you put those together, get them fairly close, you cut out your 20 gauge and you use it as a jacket, basically creating a canister kind of weld. So these guys will get welded, so once you'll tack the bars together so they're not going to shift, then you run a bead across this, basically boxing your bars in on the you know, with your 20 gauge material. Also, just as a note, I haven't cleaned up these surfaces here, and what you're going to want to do before you go ahead and do this method is you'll want those to be fairly clean. You don't want them to be as oxidized as this is. It doesn't need to be perfectly clean, but fairly clean, because your first weld is going to be go ahead and weld the jacket down. So now all this is welded in, you have those small micro environments, and in between your layers that you're going to get that a little bit of decarb, but that carbon's going to collect all the oxides off the surface and clean things for you. And using this method, in doing some of the wolf tooth patterns that I've done, even though I've had decent gaps between where my pattern, my bars were, doing the jacket, letting that soak for a minute, and then getting good compression I've had great success in closing gaps. So in general, for keeping a good tight pattern, you want things to fit together as tightly as possible. However, it is not mandatory that everything be super tight. If you're using this method, things will come together. So it's a way of creating these more complicated patterns, these more intricate patterns, and not having to be so crazy about the fit of all of your different pieces together. It's very similar to doing like a canister kind of weld. So I have the jacket welded on here. You can see, like, it's not perfect, but it is done, even where it's not perfectly welded, it is fairly tight. Some gaps and things, but that's not a big deal. It really just needs to help create that environment. So I did cut this bar in two, because I'm going to be making some smaller knives. If I were going to be making a sword, I would have left it intact. And then the method for welding it would be soaking, doing it like bringing it up to temperature, soaking for 5 minutes, welding a portion, and then doing an overlap. So say I welded from here down, I would then weld from here down and make my way down the bar in that way. But since I'm going to be doing some smaller saxes with this, I just cut it in half so that I can weld up both sets with just kind of with one go, as opposed to having to use that overlapping weld method. I just like closing up the front when I can. That way it allows you to keep as much heat in as possible. Alright, so now we've given it a good soak time of about 5 minutes. Alright, so now that the jacket is set, what we're going to do is going to come in and set the weld on the actual bar. And you don't need to hit hard. You actually want to hit fairly gently. One thing that you really don't want to do is have this taco on you. That's a whole lot of pressure on those joints. Just running it this way on the flat in order to make sure things stay as flat as possible. thing that we're looking for here to see if we have a good weld is we're watching the bar cool down. And right now, as you see, everything is cooling very evenly. If things were not welded, you'd see sections cooling more rapidly, and those sections that were cooling more rapidly would be not attached to the rest of the piece. So this is looking pretty good. So at this point, what we're going to do is use the hard wheel to grind down the jacket that we've applied to the outside of this stack. The important thing is to get all the way through all of that excess material. There's not that much of it since we only used 20 gauge sheet for this, but we want to get all the way through that jacket so that we can make sure that all of our welds are solid, which they should be. So now that we have the jacket completely ground off, what I've done is I went to the 2x72 grinder and cleaned up the surface with a 120 grit just to get a little bit more of a polish so that we can see the etch and make sure that everything is looking good. At this point right here, you can see where there is a small bit left over from the tack weld of the bars together that was underneath the jacket. But right here, it's very superficial, and that'll end up going away in the final etch. Since we are dealing with twisted stock, we want to get deep into this in order to get the really active pattern. So all of this is going to end up going away. I hope that this was informative. I hope this helped you guys out. If you guys have questions about anything, if you want to see more of this process done, if you want to see different patterns, examples of different patterns, methods, theories, all that kind of stuff, just put that in the comments. Let me know what you guys are thinking, what you want to see, and I'll be sure to create some of those videos. I hope things are going well in your guys' forges. I hope this has been informative, and I will be seeing you in a week.